PCB Foundations, by Paul Taubman and Sean Kelly. Presented by 9.Connects. Chapter 1, Introduction and a Brief History. 1.1, Introduction. In basic terms, a PCB, printed circuit board, is a mechanical platform that supports the mounting of circuit components, and provides conductive paths, that are printed on an insulated material. Although there are many aspects to consider, such as signal integrity, noise, material dielectrics, and the like, let's keep it simple for now. At the end of the day, we are simply trying to electrically connect one point to another. If we step back for a moment, and look at the big picture, the PCB is just one of several possible media, that allow components, which we're simply defining as, functional devices with a specific purpose, to communicate with each other. Some of the media commonly used by components to communicate with one another, are the following. ASIC design. An ASIC, application-specific integrated circuit, is primarily used as the medium to build components, and their interconnectivity within the chip. The medium commonly used, is silicon. RF design. RF, radio frequency, is a method of communication, in which the data from point A to point B, is communicated through waves in the electromagnetic spectrum. Antennas and waveguides, are media that are used to transmit and receive this information. Optical design. This medium uses photons and fiber optics, or lasers, to communicate from point A to B. System design. In system design, one of the main media is good old-fashioned cabling and wire. In some cases, they will also use RF and fiber optics to enable these systems to communicate. All the media mentioned above, as unique as they are, rely on PCBs for their system-level connectivity. A computer chip may have been developed with powerful algorithms to calculate complex 3D simulations, but it must interface with other devices to communicate its results. The data off an antenna is only as good as the PCB with components necessary to convert the signal into useful data, such as video or audio. Even fiber optic signals are eventually converted into electric signals via components on a PCB. In this sense, the PCB is truly the medium of electronic media. You would be very hard-pressed to find an electrical device, made in the last 30 years, that doesn't have a PCB in it. Even light bulbs now have PCBs in them. 1.2 A very brief history of PCBs. Although we do not want to dwell on this too extensively, it is important to touch upon a bit of PCB history. As our story unfolds throughout this book, you are going to wonder why they did what they did, and a bit of history will be very beneficial. There is a debate as to who is considered the father of the PCB. Two inventors have been given this credit, though the concept of the PCB as we know it today, came about long after their inventions. Americans tend to give Charles Dukas this honor, as the father of the PCB. His U.S. patent for adding conductive inks to an insulating material, is very similar to the processes used in today's PCB fabrication. However, in 1903, German-born Albert Hansen submitted a British patent for the printed wire. This invention looks much like a multi-layer PCB. The only difference was that the wires were already fabricated onto an insulating material, with each layer running perpendicular to each other. The user would simply punch a hole with a metal ring at the intersection of the two wires in order to get them to connect. Due to the materials used, it can also be considered the first flexible PCB. Most of the PCBs created today are known as rigid boards. Though they have some flex to them, bending them can cause damage. In the 1950s, the concepts of flexible PCBs were being researched and patented. Flexible boards are commonly used in devices where physical space is limited. As for the PCB as we know today, much of that credit is given to Paul Eisler. In 1936, Paul Eisler obtained a British patent for a method of PCB fabrication still used today. This is copper foil, on a non-conductive surface, that is reinforced by a weave of glass. If you are new to this field, think of it as a thin layer of copper on an insulator. Using his patent, he developed a radio, which could be considered the first electronic product built using a PCB. As for the development of PCBs, much of this was done by the U.S. military, with information provided to them by the British, during World War II. The first U.S. product to use a PCB was a proximity fuse added to artillery shells. It allowed the shell to explode in close proximity to the target, without having to hit the target. After World War II ended in 1945, there was a booming industry for appliances, especially the television set. This forced manufacturers to become more efficient with their assembly lines. Attaching individual wires to components, like diodes, capacitors, and vacuum tubes, was laborious and time-consuming. Using a PCB made this process quicker and less expensive. With the transistor being introduced in 1947, PCBs were the perfect medium for components that were a fraction of the size of a vacuum tube. The space race between the United States and the former Soviet Union, in the 1950s and 1960s, had a major impact on the advancement of PCB technology. Many of the routine practices that we apply to our PCBs today, all came from the drive to get mankind to the moon. This includes multi-layer boards, the use of vias to traverse the layers, and the use of surface-mounted components. All these concepts will be discussed in further detail in the subsequent chapters. Since then, PCBs have been evolving to meet the ever-growing and diverse needs of the electronics industry. The advent of microchips in the 1970s drove the consumer demand of personal computers, video game systems, and digital appliances of the 1980s. In the 1990s, the Internet and cellular phone infrastructures were taking form, which demanded the transmission of large amounts of data. The advent of smartphones in the 2000s drove the need for higher performing electronics, but in smaller and less power-consuming devices. The IoT, Internet of Things, and AI, artificial intelligence, are some of the current drivers to push for better technology. In all of this, the PCB has been the workhorse for making it all possible. Summary: the PCB is the electronic medium of all media. Like any scientific discipline, knowing some historical details about the PCB brings some perspective as to how the PCB came about, as we know it today.